Okay, I think I need to sit down because otherwise I don't have a head. A lot of stuff on the table. This video is about both electronics and NMEA network. And this is going to be interesting because it's going to be quite large network. I'm going to have some redundancy and fallback and fail-safe systems in the network, and this is going to be done that way that I have two separate NMEA 2000 networks and one NMEA 0138 network, so the old standard. And why I want to keep the old standard, so there is two reasons. I have a couple of old equipment which I want to keep because there is no better alternatives built after those. So I have like a 30 years old compass and a 30 years old speed lock, and I don't want to have anything else instead of those. And then of course to make this redundancy system, so I need two compasses, for example, and two speed locks and so forward. So let's see how this is going now. The boat has from early days already had a quite complicated boat network, the old standard of course. And because I've been a bit of a nerd, so the equipment on the boat, so they have always like spoken with each other. So there has since beginning, so there has been a network. And now I'm going to take parts of that old network and save it, and then install new network. Also one of the reasons I started building this or planning this new network is because the old wind instrument doesn't work anymore, so I had to buy a new one anyway. And then at the same time, so I thought that okay, why not build a completely new one. And of course the electronics, so that doesn't last forever, so that's also one of the reasons I want to have this redundancy in the system, so that if one equipment fails, so there is immediately another one that can like take that job instead. And why I want to have two separate NMEA 2000 networks, so that is because if any one of you has ever worked with the computer network, so you have probably noticed that if you have one equipment that doesn't work, so then it might take the whole network down. So it's the same actually with the NMEA 2000 network. If you have one instrument that fails, it might take the whole network down. So that's why I want to have like two separate networks. And I will also one other reason I want to have this NMEA 0183 network is because I'm going to connect those two NMEA 2000 networks together with that old network. And I'm going to make this a two-part video. And this first one is a theory only, basically, mostly, and the other one is more like soldering and drilling and installing stuff. But this first part is the one you want to watch, because all the necessary things you need to know, so it's going to be introduced in this video. So let's see. Okay, the NMEA 0183 network, the old standard, is quite simple if there is not more than one talker and not more than two listeners. A talker can be a GPS, for example, and a listener can be a multifunction display and a DCS VHF, which requires position information, for example. And to connect these together, so they use standard color coding, which you can see here in the bottom left picture. when you start building a network and of these, and if you have more than one talker and more than two listeners, so then it starts to become complicated, because then you immediately need a multiplexer to connect the talkers in, and if the output ports for the listeners are not enough in the multiplexer, so then you need also a buffer. And the buffer is for connecting then more than two listeners per port. The network I'm building now, so it looks like this. So there is a multiplexer, and then there is two gateways or converters as seen in this diagram. So for this one multiplexer, so I'm going to connect the GPS chart plotter, a GPS, a VHF radio, then this video compass and a log combination, and then Raytheon Raydata multi-display and a PC computer. But the ports are just about enough for this kind of network. When you have a larger network like this and you have a lot of information going to be fed into the multiplexer, so then you have also to start thinking about these baud rates. So the old standard for the baud rate of the talkers, for example this Furuno GPS here, so that is 4800 bits per second. And now when there's several equipment connected to the multiplexer, so for not the information to be left out from the sentences, so you need to raise the speed of the outgoing port. And the new standard is 38,400 bits per second. And this is also a reason why you need a programmable multiplexer, so that you can adjust those speeds. We can have a look at this programming in the second part of this video. Okay, so that was the old NMEA 0183 network. And as you saw from the video, so the multiplexer and the NMEA 2000 NMEA 0183 gateway are playing quite a key role in this kind of network. And when you select these, so you need to be careful that you select models that are programmable, because you probably need to filter out some information from the talkers and probably give some priorities to other sentences. If you, for example, have two compasses and you need to or want to prioritize the other one and keep the other one as a backup, so that's why you need programming. And same thing with this NMEA 2000 NMEA 0183 gateway. It also has to be programmable for the same reason. So that was it, and now let's go to the NMEA 2000 network. The NMEA 2000 network is fairly simple. It's basically just another CAN bus with a backbone with end resistors into what the instruments are then connected with the drop cables with the connectors. Like with the NMEA 0183 network, so also the NMEA 2000 network is using standard color coding for the wires. And now this Raymarine is using a different name for the same network. This is actually a standard NMEA 2000 network, but they are using non-standard connectors. So that's why they call it C-Talk Next Generation. But the color coding of the wires is the same. So when you connect these two networks together, the Raymarine C-Talk Next Generation and a standard NMEA 2000, you don't necessarily need to buy those expensive adapters. You can cut the cables and solder the wires together according to the color coding. So let's have a look at the NMEA 2000 networks now that I'm going to build. The first one is going to look like this. So that is the one that is going to have these Raymarine instruments also, which are going to have their own backbone and which is then connected to this standard NMEA 2000 backbone. So one of the end resistors of the backbone is of course going to be in the standard NMEA 2000 backbone, and the other end resistor is going to be in this Raymarine C-Talk Next Generation backbone. And what do I have connected into this now? It's going to include the Raymarine wind instrument and then 3 multifunction displays. Then controls for the Garmin autopilot, the autopilot itself. Then connector for the Raymarine, this Raymarine transducers. So that is going to include the wind transducer, for example, and then the depth and speed log transducer together with the water temperature transducer. So that is this Raymarine ITC5. Then this wireless ANT, that is a Garmin wireless connectors. Then all this is going to be connected into the NMEA 0138 converter, which again is sending all the information to the old NMEA 0138 network. Then the other NMEA 2000 network is going to look like this. It's going to have a heading sensor, a Garmin multifunction display, AIS receiver, chart plotter, and fuel and water transducers. This network is not going to have as many instruments as the previous one did, but this is going to have two instruments that are sending quite a lot of information into the network. The AIS receiver and the heading sensor. So that's why I wanted to keep the size of this network a bit smaller.